All right, so I am going to do my best to make an anchor chart right now on angles, the same way we would meet in class and draw an anchor chart together, okay? So before we even talk about angles, there's just a few things that we need to get to know. They're actually vocabulary words. So one is, it looks like just a dot, all right? And it's actually called a point, but the way we're going to be using it, it's going to be called an endpoint. Okay? It's going to be called an endpoint because it helps to form this thing called a ray. Okay? So a ray, just switching markers the way I do in class, okay? A ray consists of an endpoint. So a ray has an end point. And what the end point says is it doesn't go any more in that direction, it ends. But a ray has this line, and this line, even though I ended it right here, this arrow tells me it keeps on going and going and going. So this ray, it has one endpoint and one line. Okay, so the purple is the line. So when that endpoint and line are together, that is called a ray. Okay? Back when I used to teach fourth grade a long time ago, I used to have my students make Mr. Ray. Okay, his name was Mr. Ray Engel, and I'll just draw it for you quick. He definitely had a head, but his arms, I remember, were rays. So he had a end point and a line, an end point, a shared end point, and a line as his arms. Okay, so if you think about Mr. Ray Engel, okay, Mr. Ray, I want you to just visualize that end point and that line. And the reason that is so important, okay, is because that end point and line that forms a ray, together rays form angles. So if you even look at Mr. Ray here, he is an angle. But let me draw another one a little bit more clearly. If I have an end point, actually, you're just going to draw 3 right now just to show you. Okay, 3 endpoints. Okay, and if I have a line that goes that way, so now it's a ray because I have an endpoint and a line, and I have an shared endpoint and a line, that makes an angle. And what the angle really is it's a measurement. It's a measurement of this opening here, of how much that opening is. Okay, and they actually measure it in degrees. So you might hear somebody say like 13 degrees or 50 degrees. You hear that in temperature, but you also hear that in angle measurement. Okay, so here's another example. There's an end point and a line. I'm going to use that same end point and a line. So this interior angle, the inside measurement, would be all of this. Do you notice it's a little bit bigger than that one? Okay, they can come in all different sizes. Okay, I'm going to draw another one. Here's an end point and a line. And that same end point and a line. Wow, that is a big angle. Okay? So these angles actually have names, okay? And some of you might have heard some of this, and if you have, that's awesome, and if you haven't, that's okay. But this one is a very small angle. I always think of it, it's called an acute angle. I always think, oh, it's so cute. A lot of times when you say something is so cute, it's like a little baby puppy or a little baby chickie or a baby, okay? Acute is anywhere, it's less than 90 degrees. Okay? Then we have this one. Now this one, if you hold up a regular piece of paper, so I'm just grabbing let me grab a piece of paper. Well, let me grab my bookmark. If I just hold up any piece of paper, like our bookmark, okay, it has that squared angle. It looks kind of like a squared edge, okay? That is a 90-degree angle, okay? And so 90-degree angles, those are called right angles. And they are exactly 90 degrees. So you see that little degree sign? Okay, I'm going to even write that down so we have that. So that's just a degree symbol. It's the unit, okay? So a right angle is exactly 90 degrees. It doesn't always have to be like that. It can be there, it could be there, it could be there, okay? But a right angle is exactly 90 degrees. Now this one is a big angle, okay? Any angle that is larger than 90 degrees, it's bigger than a right angle, is called an obtuse angle. I always think of a tuba, it kind of has that like obtuse tuba. It just sounds big and deep, okay? So we have three different types to classify, or three different ways to classify angles. They're either acute, they're right, or they're obtuse, and it depends on their measurement. Now these ones, I made it nice and obvious. So you can see, oh, that's little, oh, that's perfectly square, and oh, that's obtuse. Oh, and by the way, right angles, something else I should say, is a lot of times they put this symbol to show you that it's a right angle. Okay, so a lot of times, like these ones, I made it nice and easy. But sometimes they'll draw something like, let me draw one more angle over here. Okay, and you're like, is that a right angle or is that smaller than a right angle? I can't exactly tell. And that is where, and I know you guys, I sent everyone home with one of these. That is where we're going to end up, not today, but we will be using the protractors, okay? And the protractors help us get a measurement on the angle, okay? One last thing I want to say today is I want you to know that, and this kind of seems tricky, but it at the same time, it starts to a little bit make sense. Think about a circle. Okay, the shape, a circle. Just gonna draw a big circle over here, the best I can. You know me, if I don't draw it right, I'll want to redo the whole thing. All right, not bad. Okay, a circle, if you think about how much is the angle here, okay, so if this is the end point, okay, and maybe there's a ray there, and then all the way around, and there's another ray here. How much is in the inside of a circle? I want you to take a minute to think about it. And here is how I'm gonna give you clues while you think. Well, if there was a ray here to here, we would say that was 90, right? If there was a ray here to here, we would say that was 90. If there was a ray here to here, we would say that's 90 inside. And inside here would be 90, right? So I'm talking about, I'm putting four angles together, really. I'm saying the inside of this, the inside of this, the inside of this, and the inside of this together make a circle. So if you think about it, 90, four of them, 90 times 4 is the inside of a circle. 4 times 0 is 0, and 4 times 9 is 36, which is the inside of a circle is 360 degrees. I don't know if you've ever heard somebody say that they turned 360 degrees. It means that they were facing this way, That's his smile. And he turns all the way around until he's facing that way again. So that means that he made a full 360. Sometimes I'll hear it in like snowboarding or dirt biking or something, like tricks. They say, oh, can they make a 360? That means can they turn fully around? That is a 360. Whereas sometimes, and I think again about like these tricks, sometimes people go a 180. A 180, and again, think about it. I like to think about it with 90s. It's like a 90-degree angle and a 90-degree angle. 180 means that you go this much, okay? Our protractors are 90 here and 90 here. Our protractors are, and if you can get close, you can see it. It ends with 170 and then 10 more. Our protractors are 180 degrees. So a circle, it's important to know that angles are formed from a circle. A circle is 360 degrees, and a half circle is 180 degrees. Okay, and that might be helpful as we do some other some more work with this. So for right now, this is our anchor chart. Again, sometimes our anchor charts, and now let me get a little bit higher. Our anchor charts look a little bit confusing, but if you were following along, it should kind of make sense to you. And we're going to continue doing a little bit of work with this, but if you need to look back at our anchor chart, then hopefully this can help spark some, some basic knowledge of what angles are.